So synthetic division, I just made a nice table for you. What we need to do is something that you might have seen before, but you still have to make sure that everyone knows. What you're going to do first is the coefficient of the polynomial in descending order. So for us now, it's a cubic polynomial, so the degree is 3. And then x cubic, square, linear, constant, and I'm interested in their coefficient. So if I put in the coefficient, it's going to be 1, 2, -3, 4. And what you're going to put onto this table is the root of the factor that you wanted to divide with. I want to divide by the x minus 2. And what's his root? 2 is his root. So I'm going to put 2 here. And I'm going to bring down the 1 down here, which is 1. And the outside, I'm going to multiply by 2. Right? Then you're going to multiply, it becomes 2. And what you're going to do within the bracket is that you're going to add them. If you add, it becomes 4. If you multiply 4 by 2, it's 8. Add 5, 10, 14 is your remainder. 14 is your remainder. Understood? Okay. So what does that mean? Well, from my polynomial, what I have here is that 2 was a root. That means the linear factor was x minus 2. And I divided it. That means your reduced polynomial will be now quadratic because you divide the cubic by linear. So these are the coefficient of a square, linear, 0, constant. So you have at this moment x squared plus 4x plus 5. But remember, we have a remainder. You got to add by 14. Okay? So that's what it means by the polynomial. Synthetic division. So let's have a look at a few more examples. The one that you shouldn't be confused by are the following. This one, well, a lot of people make a mistake of such as him. Let's have a look at this. Why am I saying that we got to be careful with this particular example? Is that you have a degree 5 polynomial, right? So what I'm interested in is to discuss the coefficient of a 5, 4, 3, 2, 1, 0, right? But at this moment, if I try to write in descending order, we have a 3, -8. So far, so good. So those are the degree of 5 and 4. Coefficient of degree 5 and 4. But I don't have a cubic. But I still have to think about the cubic. Why don't I have a cubic? Because his coefficient is now 0. Okay? And then the quadratic, linear, constant should be the way. If you don't see the term that you're supposed to have, that means his coefficient is simply 0. Okay, then I have a root here. And then what's the root there? Is 2. So 3 comes down, and I'm going to multiply, which becomes a 6, -2, multiply outside, -4, -8, -14, -30 will be -27. Okay, so then how can I then rewrite this? It will be that polynomial is that we multiply who and who first? The divisor and quotient, where division is going to be the x minus 2. And then since I divided the degree 5, it will be given 3x4 cubed square x constant minus 27. Okay? But I wonder if this is really true. How I can check is the following. Suppose, I have my function here, right? If I put a root of your divisor, I didn't say it's a factor. If you put f of 2, I'm going to get some number, okay? But then on the right-hand side, if you put 2 here, what does that become? That becomes 0. So whole thing here becomes 0. I'm going to only just have what? The constant part, right? And if that is really the -27, that means you divide it well. Okay? So let's have a look. So if I put 2 there, that's 3 times 32. Minus 8 times 16 plus 4 minus 2 plus 3 does become -27. So what I've just briefly mentioned is something called a remainder theorem that we are going to talk about now.